Welcome to the SJC e-content media. I am going to present to you the introduction to molecular physics. Molecular physics is one of the important subjects for the students of postgraduate. The physics laws are imbibed in everything in the world. How these physics laws could be understood in the dynamics of the molecule. When an electromagnetic wave interacts with the matter, how these dynamics could be understood, that we give in the introduction. You know, the bulk materials are composed of atoms and molecules. If you want to know the characteristics of a bulk material, you must go deeper into understanding the characters of the particular types of molecule and atoms. So atom in an isolated form, it has got certain protons, neutron, and in the outermost cells, electrons. But when it is combined, it becomes a molecule by bonding with that. So how come we can understand its dynamics? To know its dynamics, we need to have a study over that. Take for example, when an electron is accelerated by a electric field, it's a charged element, charged particle. When the charged particle moves, it produces electric and magnetic fields, which is perpendicular to the direction of the motion of the electrons. And bundle of light of that is called photon. It can travel with the speed of light in the vacuum. So this wave, a particle and wave, has got certain characteristics known as frequency, wavelength, and energy. When you know the frequency, wavelength, and the energy of a particular wave, you can say something about that particular wave. You know, wavelength is nothing but a distance between any two peaks in a wave. It is measured in meter. Frequency is number of waves formed in a given time. It is measured in hertz as number of waves per cycle. A shorter wavelength means frequency is higher because one cycle can pass through the shorter time. Similarly, the longer wavelength means frequency is lower. It takes longer time to complete the cycle. Therefore, a wave having so much of spread of wavelength and frequencies, you call this long spread of span of wavelength and frequencies of a wave, you call it as electromagnetic wave. So the electromagnetic wave has got so many ranges. Basing on its ranges, we name it as, if it is lower radio frequency, little above microwave and infrared, visible, ultraviolet, X-ray and gamma ray. We can look at this picture on the right side. The upper top, you can see energy, a red line going from left to right, increasing. The same way, the frequency also increasing from 50 Hertz to 30. And also the wavelength goes starting from a higher to lower. So as a result, the energy and frequency are inversely proportional to the wavelength. So basing on different spans or bands of the frequency, we can divide the ranges into so many types. So as a result, when the electromagnetic radiation interacts with the matter, any matter, it results in two things. One, that is absorption, another is emission. A photon of energy h nu absorbs, goes from ground state to the excited state. The energy difference between ground and excited state you call del E is equal to h nu. So this ranges different bands of the wave, also basing on its characteristics, that is, the frequency of that particular range must coincide with the electromagnetic wave that is radiated or irradiated. If the frequency are same, it absorbs and does some functions. In the lower part of the figure, you can see here, when electromagnetic wave or radiation falls in the microwave region, the molecules set into rotation. It is rotational spectroscopy. When the frequency of electromagnetic wave and the matter coincide in the range of infrared, the molecule set into vibration motion. In the same way, visible and ultraviolet, there is an electron configuration takes place. From one energy level to the next energy level, the electron jumps. That is, electronic transition takes place. Then comes the X-ray and gamma ray, where the ionization takes place. So basing on each area or each range, each frequency, different types of motions of the molecules can be observed. So basing on different types of motions, basing on different types of the molecules motion, we can classify into different spectroscopies. So in the next study, we will be starting with the microwave and then infrared, visible and ultraviolet. With that, we also study NMR spectroscopy, nuclear magnetic resonance, and electron spin resonance. These two, they change their spin by application of radiation. Like that, we will be studying throughout this molecular physics all this spectroscopy. Thank you.